Hello everyone, this is my weekly summary for week number 9, I believe. And what we basically did this week, we pretty much mastered or got all the information of how things components from the Arduino work. So to begin with, I did the resistor. This is part of my journal, what I put in here. And I like to do a lot more with drawings to understand like how it actually works. So on here, the resistor, it just, it limits the amount of current flow. So in this case, I did this drawing here, which means that it's just like a smaller tube or bigger tube, depending on what you want it to do. But the smaller tube, you see is thinner with more turns, would be higher resistance, whereas a bigger tube in this case would be like copper or wire. So the bigger the width it is and the less turns it has, it's the lower the resistance, and that we use the resistor to try to limit the current flow depending on what we're trying to do. Then I also have here the switch, this is a symbol for switch. This is the push button switch here. It can be always on or always off, so you would push it or press it on it to turn it on or off, and it just interrupts the flow of current or electrons in a circuit to close or open a circuit. The type of switch we use for the Arduino, it has these two legs are together, so they are connected. So when you press on the button, it connects it with these other ones, so you can actually do two connections with this one because it has the four legs. But most of the time we only use like one side of it because we're just trying to connect one thing with the other, but it just depends on the application. Then on here I looked the information about the LED, which is in this case this is a single LED, and then this is the one that has like the different colors like red, green, and blue, I believe it was. And then you can control the current on these to try to make different colors for the combination of the three of them. But it works just like a regular dial. Just do the P and N junction dial, but in this case they use different types of materials so that it actually, when the electrons go and jump into the holes for the diode, when it happens, it has a different type of element inside, so that it actually emits light. So that's how these work here. So like it has like gallium, I believe, or arsenic. So it just works a little bit different, but you can control it to make different colors of light. And then this is the temperature sensor, which we have here. This is a type of symbols I was able to find. This is what they use on the Arduino one, but it didn't really tell me much. So then this is like another type of symbol that you would be able to find in a schematic. And then this one, it just provides different so the component outputs a change in voltage depending on the temperature it senses. So some of the sensors are contact or non-contact depending on the type of sensor that you have. But it does this by measuring the heat energy as molecules move. So when molecules move, it provides a different type of voltage. And actually this is the power, the ground, and then this is the Arduino. So depending on what it senses here, it provides a different type of voltage, which is what the Arduino would read. And then over here, I have the photoresistor, which is the variable resistor that changes its resistance based on the amount of light that it falls on its phase. And pretty much what it does is that on this one we have the conduction band, which is the highest energy, and electrons can move freely here. We have the energy gap, and then the valence band, which is the lowest energy, and electrons move the least. So when we get light into the face of the photoresistor, then these photons excite the electrons here, which move to this part here, and because we have more of electrons here, it actually closes the system, allowing electrons to go through. So we would have like the positive and negative on this other side. And so the more light, the more they excite, so the more electrons we get on this side, and the more current flow we get. And then over here we have the potentiometer, which I did kind of like a drawing of what it looks on the inside, but it's just a variable resistor, so we can we can control the resistance. So it'll be that as we move this, we can change the resistance, and this would be the ground, the power and ground, or ground and power. But at the end of the day, as we move this here, it's going to change the resistance. So that's why it's a potentiometer, and we're going to get a different voltage difference here. And then we have a capacitor. So we have a capacitor, which this is a sign, the symbols that we would usually find. This means it works either way, however you connect it. This one means it's polarized, so it only works in one way, but not the other. And this one, it stores and releases electrical energy, which in here we have, it's kind of like two plates with an insulator in the middle. And as we apply current to it, we would get like negative. So the electrons on one side, and then the it'll be positive on the other, and through the electric field it'll push electrons through it. But at the end of the day, what it does is smooth fluctuations in voltage, so it can work as a filter, is one of the most common applications of it. Then yeah, so it can be charged or discharged depending on the voltages that we have. So when the circuit's voltage is higher than what is stored in a capacitor, it allows the current to flow in given capacitor charge. But whenever the voltage is lower, then it'll actually discharge the capacitor. So it's kind of like a battery, but at a smaller scale. And then, and this is where I was doing the insulator, and then the positive and negative plate. And it does it through the, I believe it's like changing electric field here. And then we have the servo motor, which is just a motor that rotates only 180 degrees. And it has so it has a potentiometer inside. So it's able to change direction depending on the pulses that it gets. So it gets different types of pulses depending on the frequency, and depending on what it's getting, it'll do either turn one way or the other. But it just moves like 180 degrees. And then for this one, I wasn't able to find much, but I mean, it's just the electrical component that can be used to detect vibration and create noises. I would have to look a little bit more into it. I'm not really sure how it actually works inside. As for this one, a DC motor, it just converts electrical energy to mechanical energy when electricity is applied to its leads. So it just has a coil when it becomes magnetized, and as it magnetized, it makes the shaft to spin. But if you change the direction of the current, it'll change the direction of the rotation of the DC motor, which is very useful for almost every machine that exists. And then we have the MOSFET here. This is a symbol for it. We have the legend device, that the 3-leg device that can be operated as an electrical switch. So in this one, as it's just, these are not connected, but as you put say positive here, voltage, then it attracts the electrons, and all these electrons allow current through here, and as we put more electrons get through here, then more electrons are able to go from one side to the other, connecting the circuit. And then the diode ensures electricity flow in one direction. It's kind of like the LED, but it doesn't emit light exactly, and it's just that we have electrons on one side and holes on the other, and as we we put the battery to it, it allows the flow electrons to the holes, and it also connects it closes the circuit, but it flows on one direction. So this is the anode side, which is the positive, and the cathode side, which is the negative, but it does not emit light. Then lastly, what I have over here is I also learned about amplifiers. So this is a single input amplifier here, and like I said, all they really do is they receive a signal, which is the input. This is the symbol that you would actually see on a schematic, but it's just all it does is amplifies the signal it receives. So you get this input, and then you put this output, and you would be your positive and your negative here. I mean, it's useful, for example, an amplifier for speakers. You put a little, if let's say this is a microphone, when you speak, it's not loud enough, it's just this little wave. But when you put the output and you connect it to a bigger speaker, it's actually magnifying this signal, which is what we hear through the speaker. And then in here, this is a 2 input. So what it does, it's kind of the same thing, but this amplifier actually takes the difference between this 2 and then amplifies the output here. And then, I mean, with the amplifier, you can like change the gain, or pretty much how big do you want this input to be amplified. And that's what I have learned so far about this. This is called a differential. This is a differential operational amplifier, and this is a single input, I believe, operational amplifier. But that's pretty much for this week. We also did some Raspberry Pi work, but we just kind of got the hint of it, which I know is just a small computer. You can connect the monitor and a keyboard and mouse to it. It actually works like a small computer, not like an actual computer. It's limited, but it's very useful to be able to do different things, which we'll be starting to do our project. But it's pretty much for week 9, and thank you.